So everyone, my name is Dan Ciccone. I am one of the sales/solutions engineers here at Datto. I've been here for almost 6 years, which makes me like one of the older tenured guys here. I came on board right around the time that our first generation Siris came out. When that technology dropped, it really made us who we are. The Siris platform. First thing worth noting, this can be purchased in 3 different ways. You can get hardware from us, which I'm sure you're familiar with. And that hardware will range from 500 gigs all the way up to 120 terabytes in spinning drives. Remember, even these spinning drive systems have solid state drives for their OS. We'll take a look at a spec sheet later on. Then we have an all-flash line that goes from 1 to 12 terabyte with some varying sizes and ranges within there as well. You can imagine IOPS being a bit faster there, performance and virtualization being a bit better. A little bit more of expensive hardware in that case. Now, the 2 rarely talked about ways of deploying the system, and really with no upfront cost, just monthly service, you can image a system and turn it into a Siris if it's up to specification. How do you know if it's up to specification? There is, of course, a knowledge-based article that would outline what we need on our side of the house. Just type imaged here, getting started, the Siris 3 imager. We'll talk about basic system requirements, and there's even a Ubuntu certified hardware list here as well. The other deployment is actually one of my favorite things to talk about. You can purchase this entire platform as a virtual machine. Not only perfect for testing, but this is a very compelling conversation to have with a client if they've already made a significant investment in storage. Now, when deploying a virtual Siris, the caveats and what we need to understand. First, this has to be sized the same way as our physical devices. So if my client has a terabyte of data, they would need at least 2 to 3 terabytes of free space for the virtual hard drives that I would need to create here. And remember, I don't want this on the same host server. I don't want this on the same SAN, theoretically. I want this to be separate. I don't want to cause a single point of failure within the client's environment. I don't want to be able to not locally fail over. I'll talk more about that product as we proceed. But there are a lot of different ways of deploying a Siris. The management console and everything that's proprietary about the solution, and just a 30,000-foot overview. This is a device within their infrastructure, whether it's physical or virtual, that was intended to eliminate downtime. Backup is awful. Backup comes with a lot of limitations. This was designed to provide enterprise layer uptime to people that can't necessarily afford it, and should be sold as such as well. We'll talk about some strategy later on. It's primarily an agent-based backup solution. I always like to just start with setup and deployment, and if at any point anyone would ever like to review best practices, just talk to Matt. I'll take you through what I would recommend in configuration here. Not that they're difficult to set up, there just may be things that you're missing that we recommend. I can show you how to keep everything nice and green. Okay, we're primarily an agent-based backup solution. That means that I need to install software on systems that I'm protecting, but there is this potential that I can take an agentless backup in VMware, even with our physical system. Candidly, deploying the software within the guest VM works a bit faster in the way of transfer speeds we've found. Agentless tends to work a bit better, excuse me, if you have a virtual Siris. A bit quicker in speed there. But even if I have a virtual Siris, I theoretically don't want to do everything agentlessly. I'm snapshotting through the host. I don't want to overstrain my host, and there is literally hardly any impact on a client system when you deploy the software. Remember, whether you're agent-based or agentless, we are restricted by the operating systems that we can protect. The good news, we can protect almost everything. Everything in Windows dating back to Windows 2000, that does include every single server and workstation addition through your most current. A full suite of Linux distributions that you can back up and virtualize as well. Again, if you're curious, the knowledge base, very simple, just search for Linux here. It'll give you all your supported operating systems. And although we have an Apple agent, there's no failover for Apple. Apple says that you can only fail over to Apple hardware. And to my knowledge, this doesn't work with the latest version of macOS. But remember, the full functionality of Datto NAS is included with every device. And here, where I create the share, I'm not going to create one, but after you create one, you can enable AFP here and just have time machine backups running to your share. So that's a way that you can protect those latest operating systems and still give them the same functionality that they would have if they were backing up using this agent software. All right, now once the software is deployed and the client systems are rebooted, adding them in here for protection was designed to be quick and easy. If anyone hasn't seen this in a while, it's changed recently. You would take the static IP address of the system if it's a server that's statically assigned, or perhaps it's a workstation. The IP was dynamically assigned. You'd enter the host name here. Configure that first guy with best practice, and now you'll be able to copy what you had configured into what you're adding in either individually or simultaneously. You can add in a list of systems here, and their IP addresses and auto-populate. As far as security is concerned, remember all data leaving this system is sent over a secure tunnel to a cloud server that has physical disk encryption, and that would be the case for our NAS, that's the case with the Alto, so on and so forth. But in that regard, Datto manages and maintains the encryption key, which may not be in line with an end user's compliance. You may need to enable local encryption, a feature exclusive to Siris. Alto does not have those. Local encryption works wonderfully. It just comes with a couple of caveats. Don't lose the passphrase, which is obvious. What may not be so obvious is how sizing would change slightly. When sizing out these solutions, it's incredibly important to understand the used hard drive data set. This is nothing that we want to estimate ever. We need to understand the consumed hard drive space on any physical or virtual volume that we're protecting, especially in a virtualized environment. I hear it every day. I have 100 terabytes of data. No, you don't. You have 100 terabytes consumed on your SAN, which literally means nothing to me. I need to understand the used hard drive space within the volume of the VM, not what's dedicated to it. I could have 2 terabytes dedicated to a virtual machine. It's only using 200 gig. I care about the 200 gig. So we calculate this number across every physical and virtual volume that we need to protect, and then multiply that by approximately 2.5 to 3. It's also worth noting that we have a volume level exclusion feature. I have to protect the operating system volume in its entirety. But if there's not mission critical data here or on any other volume, I can move it to a brand new volume and exclude it completely. That's how you save space. It's the only way of saving space. And again, once you've calculated that, we need to multiply it by 2.5 to 3. 2.5 standard, up to 3 if we're dealing with highly transactional systems, SQL, Exchange. Those backups are going to be that much larger. Also, where I may have a data set where it's not going to compress all that well. Let's call it 3T of data and 2.5 of it is video. Or if last but not least, you need to enable this local encryption. These are all cases where I would recommend starting with the 3 times multiplier of the data set. And all to afford you the same level of retention. The appliances themselves were designed to hold approximately 1 to 3 months worth of backup data, really not much more than that. Can they theoretically? Certainly, if you have a lot of room to work with, but you're usually sizing pretty close to the hip, right? We want to be as cost effective as possible for the end user. All right. Now, once systems are added, taking a backup is easy. We can take a backup whenever we want to manually, but of course we're looking to dedicate schedules. And the next 2 concepts are really 2 of the most important things to understand about our solution, how we capture backup data and how that's stored. The capture method is not proprietary. There's other software that captures this in a very similar fashion. The backup engines allow us to do something pretty incredible. They allow us to set consistent backup schedules with hardly any impact in performance whatsoever. We do recommend backing up at least every hour on the hour while data is changing on client systems. My mindset is the more it's changing, the more frequent I want to be, where I can also drop all the way down to 5-minute intervals here. Now, can you take backups every 5 minutes of every type of system in the world? No, of course you want to pay attention to resources in this regard. You certainly don't want to overtax it, but it's been my experience that you can do it at least every hour in the hour without seeing that they're running at all. Pretty incredible stuff. Now remember, there are other softwares that capture data in a very similar fashion. Even traditional backups do that. What is completely proprietary about our solution is the fact that we've developed a new method of storing backup data unique to our solution. No one in the world uses anything like this. There's some similar terms in the industry, but no one uses what we use. Now, why in the world did we do this? Simple. We used to store it the same way that everyone else did. When backing up based on a schedule in the past, you didn't really have an option. Your data was stored in a very specific fashion. You take a full followed by a chain of incremental files that rely on one another. People avoid using this, right? Perhaps they just take fulls at the end of every night. But now it's hard to move a full to a different location, especially through the wire. You can do differentials. There's still a chain dependency there. There still is. They might roll up every week, but there's still a chain dependency. You can lose a ton of data if something goes wrong. And now we'll review some of our limitations that I'm sure everyone is well aware of. If failure occurs using something like this, and my client has a lot of data, they're going to be down for a lot longer than I can provide with the Siris, plain and simple. Verifying backup data that it's actually usable using these older methods. Usually full system restoration, a lot of management, and just to make sure that they can actually recover and restore. If you're not consistently testing and taking the time that it takes to test, you can start a restore. One little incremental file might be lost or corrupted along your chain, and then you cannot recover beyond that point in time. That was kind of the scariest thing about using this. Is I think the big reason that people just drop fulls at the end of every night. They didn't want to run into that broken chain scenario, which is a bit of a nightmare. And when we used this, and remember we did on the system before Siris, our biggest limitation was the fact that if a client system went down, yes, we could start a copy of it, absolutely. But the time that it would take to do so was extraordinary, and it makes sense. We were compiling incremental backups and attempting to convert this data into a virtual machine. The more we had, the longer it took. Plain and simple. 200 gigs took 2 to 5 hours. And today, with inverse chain technology, that's something that I can accomplish in approximately 2 to 5 seconds for any size system. So what in the world is inverse chain technology? Honestly, it took me about 6 months to wrap my brain around this when I first started working here, but I think I've come up with a better explanation, a basic explanation. It's a bit more robust than what I'm about to describe, but if everyone understands taking a snapshot of a virtual machine, I think you'll be able to grasp this concept. This is obviously my VMware environment, but I like to refer to this because it's very similar to what we're doing on our side of the house. A snapshot of a VM is obviously a very small file that we can boot from. So what in the world is inverse chain technology? Think of it like this. We take an image of the client system, step 1. Step 2, we strip that image of its hardware identity. So it no longer matters what it was. It could have been physical, it could have been virtual in really any format. We don't care. It doesn't matter to Datto. We convert their system into whatever it was, into a virtual machine, and here's the other half of the secret sauce. We store it in the most sophisticated file system on the planet today, in my professional opinion. Every Datto appliance, from a 500 gig unit to a 120 terabyte monster to any one of our cloud servers, they're all using a file system on the storage array that was built and designed for unimaginable amounts of data in data centers. To that point, the Z in ZFS stands for zettabyte. It's approximately 1 billion terabytes. It's 128-bit in architecture. It's incredibly fast. It has all sorts of things built in for continuous integrity checking and automatic data repair. If you're not familiar with this, read more about it on our website. Wiki this. Learn as much as you can about this file system. It's incredible. It also comes natively with a snapshotting feature that's very similar to what we find in virtual environments. So I want everyone to picture that based on our backup schedule, I'm essentially snapshotting a virtual copy of the end user's production system, whether it's physical or virtual on their side of the house. What does that mean for you and for the clients? What are the benefits of what we developed? The first benefit is that we're completely decoupled from any type of a chain. There is no chain dependency in our backup. There's no threat of a broken chain in a Datto solution. If for that one reason alone, we convince people to stop using traditional methods, it will be worth it for everyone. More importantly, I don't care how big their system is. I don't care how many backups they've taken. Every point in time that you protect them is a snapshot of a virtual copy of their production machine. When failure occurs from anywhere in the world, you'll be able to start a copy of their production device within our platform, and that means on our device, in our cloud, on their hypervisor, in a matter of seconds. You can eliminate downtime to practically nothing. And I promise I'll show off that functionality in a little bit, but before we do, I want to talk about my favorite thing that our system does and the improvements that have just been made here. We were really the first ones to develop anything like this. Screenshot verification is a direct benefit of inverse chain technology because it took hours to boot previously. Now it takes seconds. This means that you can today schedule virtualization to occur to test bootability, and that's all this ever did in the beginning. It would take a copy of the client system, start it, take a picture of the results, and then email these results and both success and failure to different people. You could have success going straight to an end user, while you, monitoring the solution, received perhaps just failure. You don't necessarily need to see success today, especially because you could just monitor success right through your portal. Success should show us the login screen of our protected system saying to us that the backup worked and I can boot Windows without issue. And that's all that's ever really tested initially, which is incredibly important. If you can't boot Windows, you can't do anything. It's my favorite feature, not because it recognizes success, because it proactively recognizes failure. And if we think about how cool that is, when do we typically find out that something is broken with traditional backups? If I'm using something like this, when do I usually recognize that the worst case scenario has reared its ugly head? When we're restoring the data, which is a nightmare in the way of management, as we all know. In line, as we protect an environment, if a screenshot fails, it's not really a panic-inducing event. There's three things that could have happened. The client server might have an issue. You'll have to start it from when it was healthy. There could have been an error the first time it attempted to start at 2 a.m. Okay, I can test 2 a.m. And then, of course, last but not least, we could have an issue with our hypervisor, but even if that's the case, and to the point I was making earlier about not having a chain dependency, if you cannot fix the issue on your own, you'd excuse me, of course, reach out to our 24/7 support, and hopefully in a very timely fashion, they'll help you address the issue and verify that your now latest images are good moving forward. Once you've done that, and again, to the point I had made earlier, if this is a non-bootable image, I can't do a file restore from it, it's broken, I can't do anything from it, I can delete it absolutely free of consequence and still restore their system from above or below the point of deletion. These are not incremental backups, even though they look like incrementals in their size, for lack of a better word. In that regard, they are. But really what they're showing us, the size is generated by the block level change that occurred. And you can think of them more as a snapshot of a virtual copy of this production machine. That is part of the magic of inverse chain technology, certainly. And a big reason that we want to pull people away from using traditional methods. You'll have some peace of mind. So will they? You'll be able to sleep at night. Okay, we'll talk about another benefit of that in a moment, but I need to talk to you about all of the new verification, because again, all this ever did was test bootability. And if you can't boot Windows, you can't do anything. So it's step one. But does seeing a login screen tell me something about running anyone's business if their server goes down? Not really. We need to understand a lot more. That's what we heard from our partner base. And remember, we're always consistently improving the solution. Outside of the scope of screenshot verification, I want you all to take a look at what we've developed today. Please make sure that this is on your systems. It may not be. It may be disabled. Just double check that it's on. At the completion of every backup, I'm now doing a check disk on the image. I'm making sure all the volumes have the correct amount of data, and I'm making sure that I can talk to VSS. And I'll show you where to check this stuff if it's not working. This will come into your portal eventually, but right now you have to look at the recovery points page. I know if we have a ton of agents, this is a pain, but today we really do have to just come into the recovery points page. And you may see one-offs here. It's not the worst thing in the world, but if you see, for example, that VSS is failing consistently, check the writer on the host system. If you see that the file system verification is failing consistently, yeah, you probably want to do a check disk on that client system. If you see that all protected volumes are not showing, okay, contact us in that regard. Figure out why we can't see the volumes that we're supposed to be protecting. I promise all of that will come into the portal very soon. We're also actively scanning every single image that we record for early stages and signs of ransomware. I think everyone understands how big of a threat this is. This is not a replacement for AV software. It's not 100% foolproof. If you receive this notification consistently, it's saying that the metadata on the client's image is in line with systems that have had ransomware on it before the infection occurs. This can really save someone from having it. But remember, even if a system's infected, I'm going to show you how to recover. They will literally never worry about paying the ransom ever again. And honestly, I can't believe hackers figured out how to make money with viruses, but they did. And what I always say in this term is, especially when we're talking to end users in the sales process, look, you could have a valid backup. And if ransomware hits you, the time that it takes to do your restoration might be more expensive than the ransom itself. Now, I'm not telling you to pay the criminal. I'm telling you to get something that will eliminate your downtime like this. All right, verification. Just about 8 months ago, we released this feature. Some of you may have seen this. You can upload a PowerShell script here. And this would run through when verification is done. And if your script runs through successfully, you're good. And if it doesn't, it'll trigger a warning notice. It's cool, but it's not intuitive. Out of the 14,000 different partners we support, there were like 5 shops using this. There are some example scripts on the download page. You can still use it today, but take a look at what you can do today. With the click of a mouse, you can make sure SQL can start, DHCP, Active Directory, DNS, and guess what? Any other essential service of their system pulled directly from their device. This is not some arbitrary list. This is pulled directly from their appliance. What we're saying is that you can verify bootability and a lot more than that today. For example, that backup services are able to start. That's important in a failed over state. What would happen to my storage if I can't delete backup data? The appliance would surely fill up. I'd have to archive, delete, and start over. And I'm imagining I have 10 of these appliances. Okay, that's a full-time job for somebody. That's a nightmare. Today, with the ability to delete comes another amazing benefit. We set auto-deletion policies per system that hold the data for approximately 1 to 3 months. This is not our long-term storage. Of course, this is here in the cloud. We've also made cloud storage very comprehensive today. In the past, you had to purchase space. You were bound to run out of space and pay us more money. We got a lot of complaints about that storage plan, the price per gig model that everyone else uses today. We offer you time-based retention. That means that you either pay for a year's worth of data, we auto-delete after the year, or you tell us to hold it indefinitely, and both of those plans are at fixed cost. It's a lot easier to build out a contract with a client when you know what they're going to be paying you every month and how that's never going to be changing. Now, as retention processes here, it's worth noting that the images will grow, but the solutions are generally in place for years without having to upgrade. And if you have to upgrade, I'll let Matt talk you through our upgrade path a little bit later on. But the systems were meant to grow with the end user, certainly. All right, next, the sizing methodology and why this is so incredibly important. Let's talk about undersizing. Right, this is a 1 terabyte unit when it's empty, and if I didn't follow best practices, let's imagine I backed up one system that contains approximately 650 gigs of data. Excuse my crude drawing here. Doesn't look like the worst thing in the world, right? I still have 35% free. What's the problem? In failover, in replication, in everything that we do, really, we don't touch this image. We make a clone, a copy of it, and especially in failover, if this server went down, this died, I would have to start a copy. The copy is technically seen as a new device on their network that I have to back up. The first backup I take is going to be of near equal size to what I've captured initially. In this regard, can I fail over? And the answer is no, right? I don't have a free 650 gigs. Next is replication. Very quickly, how do we get data from here to here efficiently? You're typically copying it onto a drive that we provide you with. It's called a round trip. Every single system that you purchase comes with free drives that we provide you with. There's no cost for the drive. There's no cost for the shipping of that drive, UPS ground anyway, from and back to the data center. So you would record your full and subsequent images. As they're recording here, you're copying the data onto this encrypted drive, shipping that directly to our data center. And we can see data at a much faster rate than upload bandwidth can typically handle. Beyond the initial image replication, remember, you will only be sending off-site what's changing based on the block level change occurring across their network. We are tracking that on both daily and weekly basis here. You also have bandwidth throttling built in to ensure that people do not notice that replication is happening. Default limits are traditionally 80 to 90% of what the end user has available in their upstream, although if they have a ton of bandwidth, that might be throttled right here. While they're busy and working, I would recommend using just a fraction of what you had set here, perhaps 25, 35, 45%, whatever you feel comfortable with. Once you throttle bandwidth, the device will literally tell you how much data it can replicate in ideal scenarios. It's also tracking what's changing. If the average rate of change is smaller than what you can send to the cloud, you can achieve consistent replication, which is what I recommend, not the default once per day. Question about round trips. Is the Utah data center not set up to receive them? Seems that more logical to send them to Utah than the PA. Well, here's the issue. PA holds everything, all of the retention. Utah is only there to hold the latest 90 days in your full images, so everything has to go to Pennsylvania first, and then out to Utah from there. Unfortunately, they're not equal data centers in their size and scale. When it comes to monitoring replication, you of course have the portal. You have control when things turn red here. But as importantly, I want to make sure that everyone understands that every single device, when you click on its host name, has a set of alerts right here that are meant to let you know if there's something wrong with your hardware proactively, if it loses power or network, if you're out of sync with the data center, if you start recording backups larger than average size, if you're running low on disk space. Proactive recognition of potential problems. All right, next. Let's do some restoration. Okay, recovery features. Very quick, I'm just going to show off file and folder level stuff. I know that this is still the most common use for the system, and I want to show you your different options here, and I also want to talk about the speed of ZFS. I'm going to cheat and delete this presentation off my desktop. I refer to that as cheating because, let's face it, I know the when, where, and what the file name is, and that's hardly ever the case with an end user. If you don't know when the data was deleted, You're not going to come here and start mounting individual points in time and searching through them. That would be a tremendous waste of your time. You're going to use backup insights. I'll show this off in a second. In our case, I know exactly where I'm going. Select the file restore capability. I have points in time that date back just about 1 to 3 months. If I needed to go beyond June, I'll show you how to get to the data center data as well. That's in the partner portal. Now, in this case, the data set here is relatively small, right? There's not much here. It's like 55 gigs of data. But I want you to consider how quickly I'm about to make an exact copy of 55 gigs of data from 3 minutes ago. This is the system I protect every 5 minutes. Ready? It's already done. Now, how was I so confident that it was going to happen so quickly? Well, because ZFS is incredible, and it always works that fast. And for larger data sets, it will be a couple of seconds, but this is a file system that is 128-bit in architecture. It's super fast. But more importantly, it's working on copy on write clones of data. I cannot stress the importance of that enough. There's a lot of backup solutions that do restore from live image. We don't. We make a copy of the copy, and we can make copies really fast in layman's terms. Now, browsing through here, let's say you need a folder, and you're not concerned with permissions. I say that because permissions will be stripped away as you do your recovery through here, but let's say you need a folder. Click the blue link on the outside. You're downloading a compressed version of that folder through the internal network infrastructure of the client. Remember, you have 10 gig network cards in here standard. You're not touching the internet to do this. This is all on the device itself. File level recovery. So click and a download. If you need to retain permissions as you do this type of recovery, in the past, you had to contact support. Today, you could head to the same download site that I outlined before, and approximately 3/4 of the way down the page, you're going to find this little utility. Download the utility, put it onto any client system, install it, log into the Siris. Once you log in, select your agent, choose your snapshot for recovery. This does not communicate through NFS. As you mount it for restore here, you'll notice that a new logical volume just popped up on my machine. Right? Given that it's seen as a new logical volume, all of my permissions are intact. If you need a root folder and you need to retain permissions, this is how you want to do it. It's the only way to do it. You're not going to want to sit there and restore all of those individually. Okay, next. If you don't know when or where you're going, don't mount every point in time and start searching through them. Please use this. This is a feature proprietary to Siris. I'm going to give you some excellent use cases. You can literally compare any two backups that you've taken. I'm going to compare my earliest with my latest. The mounting should be fast. There's point 1, point 2, just like a file restore. Calculating differences is going to vary system by system. Just be patient here. This will eventually show you every single file that had been modified, deleted, or added. When you expand all folders, that's going to vary system by system as well. But lost data, where it used to exist. If you know a portion of your file name, use the search feature. Start searching through here, right? The find feature in your web browser. Just browse through things. You're looking to assess where growth had come from. All the files in green. Took a huge backup. You got a high local activity alert. Or my last use case, my favorite, the file system's completely encrypted with ransomware. All the extensions have changed. Here's where it was healthy. Once you've identified that this is the healthy point in time, I'm going to show you how to push data back to this point, or how to virtualize this, virus scan it very deeply, and restore it while it's running to another system. I'll take you through both of those scenarios in just a second. Before we get into those, I did want to mention one last thing here. It's in terms of granular recovery for highly transactional database systems. There is a fully licensed copy of Control on-track power controls built into this system for free. I cannot understate how awesome this software is. If a client has their own Exchange server or SharePoint server, I know a lot of people move these services out to the cloud. That's why we have our SaaS backup application. SQL tends to stay in-house always. That's too transactional to run in the cloud. If you use the software, let's say something were corrupted at the table or row level here in the database, the last thing that you're going to want to do is turn it off, use the built-in Microsoft process to recover data. It's not fun. Good luck reaching out to Microsoft for help and support anyway. It's a bit of a nightmare. I've done it myself. This software, if you use it outside of a Datto solution, is awesome. You can extract granular data from any live database while it's running. It comes in handy with e-discovery tools, and I believe, for lawyers and things like that, if you're looking for something out of the Exchange, an individual mail message. The true benefit of using this with us is that from any backup that you've recorded, you can extract that granular data and re-inject it right back into a live database while it's running. If you need help using that, just contact our support team, but it works in conjunction with our file restore feature. It's actually pretty simple to use. Next, the failover concept. When a system crashes, you should be made proactively aware of that. The Siris is always pinging what it's protecting, so if it starts failing consistently, it's probably down. You'll likely have a call from the client if you don't reach out to them proactively, and this is how much downtime people experience with our solution in place. You select the system that had crashed, and in the early days, this was the only place that you could start it. Gen 1, this was the only thing that you could do. The problem is that almost 10 years later, virtualization is everywhere, and we have to deal with much larger single points of failure than one server going down. Now, if my client has an all-physical network, or if they only have one server, one host server in a virtualized environment hosting 10 VMs, I have to account for their largest system crashing and make sure I have enough CPU power here, and I can potentially run some in the data center, but that works like an Alto, right? That's running through a VPN tunnel in our cloud. It's worth noting that even with an Alto, if that virtual machine is running in the data center, you're not recovering from the data center. The VM running in the cloud is backing up to that local storage. That's why Alto, in a 2 terabyte system, cannot back up more than approximately 700 gigs of data. And then last but not least, here, in our much larger environments, let's say my client has 4 host servers, they're all running 10 to 15 virtual machines. They have a SAN that represents a large single point of failure, and they're having a really bad day. Their SAN just had multi-disk failure. Can I start upwards of 40 or 50 or 60 VMs here simultaneously, continuously back them up with the performance that my client needs? There's absolutely no way. It's just never going to happen. You're going to run out of CPU and RAM. That's why this is one of the biggest upgrades we've ever made to our solution. We can, will, and should be integrating every licensed VMware host server that my client has, 5.5, 6.0, 6.5, 6.7, with our solution, with any Hyper-V host that they have, 2012 R2, 2016. And the main benefit of this is not being able to take agentless backups in VMware. The main benefit of this is that in local failover, where I may lose storage, I can virtualize on the host server. I can use the CPU and RAM of very powerful systems outside of our device where I'm acting as the storage temporarily. Because remember, even though I'm virtualized on the host, the backups are running here so that you can do the restore from here. But if you go back to my scenario, can I very easily provide my client with uptime and the resources that they need? Yes, their host servers were fine. And again, what's the likelihood that every single host is going to die simultaneously on that client network without it being a site disaster? It's probably not going to happen. If they have multiple hosts, hosts generally don't run at 100% utilization in CPU and RAM. So every bit of available CPU and RAM will become available to you outside of what you can run locally and in the cloud. That's the power of Siris. This comes into play drastically with our virtual product because the virtual product cannot do this. There's no hardware. The virtual Siris can only virtualize on the client's hypervisor. And that's kind of a local failover feature if we consider that. But let me hop into my virtual Siris. The virtual Siris is identical to the physical in one difference: the fact that it does not have a local virtualization feature, but it can do this. Okay, so failover. I'm going to boot this guy on the local appliance because I also want to talk about the rescue agent here. You can use rescue agents when you're virtualized via the hypervisor as well. The rescue agent is a relatively new concept. As you start the virtual machine, they always boot with DHCP for very good reason. Somebody could have left the original host server online. We don't want this booting with the same IP address. It's to avoid an IP conflict. So you're always tasked with starting it, logging in, reassigning the original IP address. As you did that in the past, you would then have to come back to protect, repair communications, start a backup, and wait for the backup to complete. And if it's a big image, it could have taken a very long time. So the rescue agent really helps you circumvent that time. It's cool. As we started. And by the way, your options here, you can boot it disconnected to test bootability. Let's say a screenshot had failed. You want to come here to do some further testing. This is your sandbox where no settings are saved. It's essentially like snapshotting a physical system, which is really cool. You can do software testing on physical devices here risk-free. No settings saved. Just turn off your VM after you do your software updates, your Windows updates. And then, of course, last but not least, live on any network they have. As you create the rescue agent, it's going to say if the source is down, I'll stop backing it up for you if this is real world. Or if you're just testing the feature, I'm going to keep backing up the original agent and your new rescue agent automatically. The neat thing is it doesn't take any longer to boot. So from a down production device, this is the fastest here on the appliance itself. On my virtual environment, let me boot this one to the hypervisor just so you guys can see what this looks like in ESX. Of course, we can do this to VMware as well. I don't necessarily need a rescue agent in that regard. The one on my, okay, this guy's already booted on my physical data. And the neat thing is, as soon as it was booted, if we look at time, 11:48 a.m., I've already snapshotted it without having to go through the whole volume. So now I reassign the IP. People are up and running and working, making changes to this virtual machine. This one is still preparing, so it takes a little bit longer. But you can see it's in progress of creating another one here. We'll let that run here for a moment. So from the storage contained within this virtual machine, I'll be booting a new VM. That virtual machine is going to be backing up to the storage until I'm prepped and ready to recover to another one. Okay, that one's just about ready. You can see it's creating those virtual disks, but where it's creating them within the storage of the virtual appliance or potentially within the storage here. That's just about ready to launch. Creating the VM now. Let's go back to the host. There it is, the dash active right at the top here. And I can access it through here, of course, right through the console here as well. Pretty cool stuff. Here we go. All right, now, while changes are still being made and without having to turn these things off like you had to in the past, very deep, dark secret of Datto for a very long time, you had to turn this off and recover the data by doing a full system restoration back to a physical device or exporting a thick provisioned virtual machine and downloading it. If you have 4 terabytes of data, anyone top of your head how long that's going to take over a gigabit internal network? The answer is way too long, no matter what it is, because you don't have to turn them off today. I can do the recovery while they're still running. We call this fast failback. Here's a little visual aid. This is the old process. We've always been good at failing over. You had to turn it off, copy the entire image. Today, I'm going to show you how to copy the entire image while they're still failed over. This way, when you return to production, downtime will be minimized significantly. Okay, step 1 in the recovery process. Head to our download site. About halfway down the page, you're grabbing this little ISO utility. If you're doing a physical restore, you load that onto a USB stick, make your stick bootable, boot from the stick. This is completely bare metal. We've already stripped out the hardware identity of the original appliance. Now I'm re-injecting that based on the 40 to 50,000 different device drivers we have built into our library. We update those consistently. You can also inject your own drivers when you're doing physical restore via USB or NAS, so very cool there. Virtual recovery, very similar process. You just load this into your new VM. So let's imagine that I have now repaired my storage. I've created a new virtual machine. I've already carved out this guy's storage. I've downloaded the ISO. I've already loaded that into my virtual CD DVD. And now I'm booting the virtual machine from that image. What's nice is when you pull up this console, when you actually boot from that utility, this is the screen that you're going to see. And in physical recovery, it pulls an internal web address. Honestly, in every regard, don't work within this window. Just browse here. Performance is a bit better. Just go to that internal web address. You'll notice it's the same tool I used to image a system and turn it into a Siris, the solution I had mentioned at the beginning of the presentation. It's also what we use to do rapid rollback. This is new from Datto. We really have to insist that when you protect systems with our solution that you disable shadow copies, previous versions. That's like taking backups on top of backups. We can't do that. That would result in tremendous amounts of data change and extraordinary growth. You have to disable that. But let's face it, that's a really useful tool in Windows. This allows you to do the same exact thing. You simply boot this utility into the existing VM or physical device, log in, select the machine, the point you want to roll back to, the volumes you want to roll back. Let's say only one was infected with ransomware, for example, and then review and confirm. You're pushing data back to a previous point, just like previous versions in Windows. Or, of course, to accomplish the bare metal restore. I'll log into my Siris. I'm going to select the system that changes are being made to. In this case, my rescue agent. I want to initialize the restore for my latest recovery point, but everyone knows that if that's a very large image, it could take hours or days to get here. So I'm going to continuously mirror. It's as simple as that. Auto partition the machine, review and confirm. And now any new backups, as it takes hours or days to get here, will be automatically injected from here into your restore. Eventually this would catch up and say, okay, I'm going to turn off from the Siris, tell everyone to stop working here momentarily. I'm going to turn this off. and reboot here, but as you do that, you're not asking for the entire image to be transmitted. You're talking about the latest backup, and that's it. So what was taking just absolutely incredible amounts of time in the past should literally take you a matter of minutes today. That was really the most important thing that I wanted everyone to see. From start to finish, in local failover, the more common occurrence, we're talking about minutes of downtime in the beginning, minutes at the end today. The last thing that I would like to discuss on these types of calls is, of course, disaster recovery. I'm going to cover this relatively quickly, but if anyone has questions after the fact, we can discuss it. Every bit of the same technology that I've been showing you exists on all of our cloud servers. You'll have access to the cloud data right through the Recovery Launchpad in your portal. If you need to go back in time, this is where you're heading. You can export images in virtual formats and download them. You can even download them through SFTP as you can with your file restore data, or of course you can start systems in our cloud whenever you would like. You can do this in your own testing, but we also do offer you free disaster recovery testing, which is huge. Given that the same technology exists on all of the cloud servers, it truly does not take long to launch these images in the data center. It's a couple of minutes per system. And because we can do it so quickly, that's why the testing is so important. This test will not turn off someone's network to run them in our cloud in type of a real world failure, because I can't get changes back to them. They'd have to download their entire data set and fully restore their healthy systems. The testing is here more for orchestration so that we can really document what we need to understand about that network before their building burns down and it's not there anymore. So the order to bring up their systems, IP schemes, special firewall considerations, how do they need to get connected here? From a client perspective, they need power and internet. But you want to make sure that you're doing this with us consistently, at least once per year, so that we've documented what we need to understand and then given you a ticket number that outlines recovery. Once we've done that, that's really your magic ticket. If disaster strikes, as long as you're prepped, the end user is not going to have a lot of downtime. If you're monitoring to make sure that their latest local backups have offsetted consistently, that they're healthy and bootable, and a lot more in our new verification process, and remember, if any of this stuff's broken, the device is going to tell you literally, and you have your test complete, you can set realistic expectations that people should and will experience less than 24 hours of downtime. Usually it's about a half an hour to a couple of hours, really. So now they're connected and running and working in our cloud, but this is not an ideal scenario. Of course, right? Their download bandwidth is dictating performance. We really look to limit the amount of time that they have to run in our data center. How do they get connected here? Anywhere that has power and network, I'm going to give access to desktops of systems if you protect your workstations, or perhaps they have remote desktop services. Beyond that, we provide public IP addresses at the time of disaster, and now I can give open VPN software to clients. They can have all of these systems appearing live on the network they're working from. Perhaps they're working in a centralized location. That ISO utility can be loaded into a Windows-based system. This can act as my gateway for a site-to-site VPN tunnel in our cloud. We can also do that. So they can really work from anywhere. Now, at this point, I want everyone to imagine we're a cloud-only system. Can you imagine the time that it would take to download this entire data set, call it 4 terabytes, and start restoring their environment? That would be a lot of downtime, right? So to avoid that, in a true disaster, Siris is probably gone. Let's imagine that this were destroyed. Okay, we'd work with the client, their insurance company, and replace the unit. As soon as we get the green light, we're going to build them another one. The new one that we're building takes precedence over anything that we're building, and we don't just send them an empty appliance. We load their cloud server. The cloud server has been capturing data as it's running and hosting their systems. Remember, this is essentially a Siris. It's not only running their environment, it's backing them up as they run and work from here. Simultaneously, I'm now seeding a Siris with the majority of their data. Once this has the majority of the data, I overnight this. Once they have the new Siris in place, I turn them off in the cloud. I'm going to tell everyone to stop working here momentarily, turn off in the data center after we take the last backup, of course. Download not the entire image set, that would take forever. The latest 24 hours worth of changes that had occurred, turn off in the cloud, run local, recover local, using the same method that I outlined before. That's why I went into such great detail there. That is a very thorough run through of our flagship solution.